Yo, what's up, everybody? Welcome back. Today we are working on making a regex engine in the Linux kernel, because I think it would be fun. So context is maybe like a month or so ago, a bunch of computers went down. World full of just blue screening computers. And as far as I understand, with basically no research, is that there was a regex engine in CloudStrike's antivirus or something, right? And they shipped an update to like the patterns that they're matching against to say like, oh, don't run that file. That's bad file now. And by updating the regexes that they were matching files against or something, I don't actually know, right? But that's kind of my guess. They ended up triggering this edge case in their regex engine that crashed the kernel, like hard crashed it straight on boot. And I saw that and I was like, that sounds fun. I want to do that. So our plan is to also put a regex in the kernel engine in the kernel. But since we're on Linux, we can't blue screen. We can still crash, but the real problem is the screen, not the crash itself, right? So the plan is I want to make something that's like along the lines of you have some function and you want to be able to like, say that you have a file descriptor that comes from opening dev regex, right? And then I imagine that you can like basically write some stuff into the file descriptor, right? Something like this. I don't remember what the calls look like, but And then I'm imagining that you like read back into some buffer. And I'm assuming that like buffer here will have your input filtered by some regex. And so we need some sort of like out of band way of doing that. So I'm imagining that we're going to do something like ioctl on the file descriptor, set regex to, my regex. This is what I have envisioned. I want to also try making the kernel module in Zig because I think that would be fun. Yesterday, we got to the point where we had kind of a sample, like a virtual machine set up with like the world's smallest RAM disk using BusyBox. Calling it world's smallest is probably a lie. A very stripped down RAM disk. So it's just BusyBox as like our environment, as well as our ability to like load a loadable kernel module. So where we got to was we have, what do we call it? It's like dev regex interface.c. We have a C file that has some like implementation functions that it depends on. He registers with the init system with these like init, exit, module exit. These are like just basically depending on if you're compiled in or out. I think that these are the differences. And then this just calls into our Zig function from dev cat dev regex impl. Who has like an external reference to print k, and he prints hi from Zig, bye from Zig. And so if we run this thing, we see that our init script ran hi from Zig. So if I say like cat init here, we see that one of the first things it does is it says insmod dev regex. And then if we see hi from Zig, and if I rmod dev regex, nope. What's it called? Hold on. Mount just proc. Mount ls proc. It's broken. I think it's rmod, maybe Zig kernel module. Nope. There's a way. Oh, we recompiled our kernel last night or earlier today, and we don't have module unloading support. But if we were to unload our module, we would say bye from Zig. That is what we would see. But we can't prove that right now. We can prove it in a second. So let's just, I'm going to quickly package that up while we're talking. Because that's going to be useful in a second. So I think it's modules in here. In here, we want a module unloading. We need that enabled. Very important. Very, very important. Okay, so the plan for today is we have like our simple kernel module example set up. And we want to extend that into like actually doing regexy things. So we're going to have to start by making a dev regex thing that we can work with. Then figure out how to like do that like ioctl call to like set the regex, then figure out how to like pipe stuff in and out and actually run the regex. Simple. And that's the plan. Let's jump in and see what fucking happens. So 0450. Make dev regex echo back input. I guess we'll wait a second because we have to wait. The kernel has to compile. We have to let him compile, right? And once he compiles, then we can say we're starting. Perfect. So actually before, let's just prove that unload case. So we should be able to remake our module as well. So make, what is it? Make dash C this shenanigans. And now if we rerun our test case, rmmod dev regex. Buy from Zig. I told you guys, I'm not a liar. I'm not a liar. It works fine. It works fine. We just screwed something up. Okay. All right. So, first step, get some sort of dev handle. So yesterday we were experimenting with the idea of doing everything in Zigland. It turns out that like the Zig C preprocessor or like the like C to Zig translator is not like good enough as far as I can tell to translate these like complex kernel headers. So instead we're going to try to work with the Linux interface in C, and then we will use Zig for everything else. So there is some, god damn it, why does it say bookmarks there? There should be, oh god damn it, here we go. This page on how the hell do you make a dev device. So these things are called like character drivers, if I remember correctly, and it's because you can echo characters into them, would be my guess. Yeah, so we used to do register a character dev region. So if I remember correctly, if I do like ls-l dev, these things all have like major and minor numbers. So like, you know, my TTY is major number 4, TTY0 is major 4, minor 0, TTY1 is 4, 1. So we need to like pick a name that will work for us. I don't really know how to allocate a name, so we will just maybe pick one at random. Maybe we will Google how to allocate card, which major minor dev numbers am I allowed to use? Use of major minor. So this is saying the same thing. Of course, now it's dynamic allocate. Can I just ask for one then? Linux dynamic allocate major minor number. This doesn't look like it's going. Hello, what's happening? Ah, get away! Accept. Statically allocating, blah blah blah, blah blah. Dynamically allocating, alloc card of region, first minor, count. Yeah, okay, so that's kind of what we saw here, right? Alloc card of register. It was alloc card of region. It is recommended to be dynamically assigned using alloc card of region. Perfect. I like that they say you can use these, and then they say we recommend to use the dynamic ones, but then they immediately have to use the static ones. You know, you're doing niche stuff when you end up on one of those sites. Yeah. Okay, so it's okay. We will try to use alloc card of region. So this looks like it comes from Linux FS. So let's start there. I should have fixed my Clang D. I think this is actually possible. Actually, I think this is possible. So I think it's in tools. There's somewhere in tools where we can like generate a compile commands thing. I just can't remember where it is. Build. Generate compile commands Linux kernel. This is important because I won't be able, like, I'm too stupid to use my editor without a proper environment. So there's like some script somewhere. It's generate compile commands, maybe? Compile commands. Like, can we just... No, I was sure there's something in here. Gen star. Maybe I'm misremembering. Well, we will live in pain then. That's fine. I changed my mind. I know I just said I'm too stupid, but I'm not actually too stupid. I'm just a little bit, like, it's just frustrating. But it's okay. So let's go over here to Linux, and we can just look at fs.h by ourselves. Nope. Linux fs.h, thank you very much. And we're going to look for alloc car dev region. We'll start there. So this thing needs a dev t. What the fuck is a dev t? What is a dev t? First. Oh, so this looks like maybe, yeah, it's weird. Can we look for an example? Grep's a little slow, eh? Oh, I see. I see. So he passes in like a thing that is output here, because this is where he's initialized. Okay, okay, works for me. So here we can say, so he did this as like a static. So we'll call this our, I don't know. And is this really the only place it's used? Yeah, I guess this is on init. So here we say alloc car dev region from dev t. I guess maybe we should call it regex dev t. That feels a little nicer. And I think actually post fixing with underscore t is actually a little sketchy. I think that those are reserved words. Not that we are going to be conflicting with, POSIX or anything, but fine. What is minor mask here? I guess this is defined externally. So let's just copy them. Because I don't know what I'm doing. And it would be actually nice to see like int alloc car dev region. Like what am I supposed to pass in here? Output number, base minor, the number of minor numbers required, name. I guess we only need one. We should just put one. We only need one. And the name is going to be regex. Okay. And then we return errors if it fails. So if this is not equal to 0, I guess we return. We do like int error here, and if error is not equal to 0, return error, I guess. And let's start there. Let's start there. Because we're too stupid to know, like, we don't really know what the fuck we're doing, right? So we might as well run first and make sure that, like, okay, so we are seeing high from Zig, which is like a good sign that, like, at the very least something has happened. Now what's the next part? So we have our thing, and he then has devs I. Where is his devs? He has my device. Okay, so our dev t is like, what is in this dev t? Struct dev t. We do need to search, not what was I trying to say? I was not grepping. I was looking at file names. This is not what I want. Oh, I guess it's not a struct. This is, can we look at like, oh god, where does this come from? Type def, dev t. Oh, type def, dev t. This needs to be an E, I guess. Here, type def ulong, dev t, types a kernel dev t. So this is just like a fucking number. This is just a number. Which is kind of confusing. Why does he need this then? I guess we'll find out later. Okay. So it's weird to me. Oh, here, cdev add here takes in the device. Twitch thinks I should watch in 180p, not a typo. That's crazy. Okay, so let's allocate. So I think dev is like, I'm not going to pretend I don't remember what that is. But cdev seems like the thing that is like our device. And it looks like what they do is they have like some sort of operations that they define that they can run on their thing. And then they add that thing. Chillin'. So let's just for now say that we have one of those. Yeah. Regex cdev. I'm sure there's a better thing to do later, but we're not going to right now because we don't know what the fuck is going on. And I think we probably need Linux cdev here as well. Tentative definition has type. Oh, he's right. Obviously, my language server is out to lunch. So here we need to initialize that thing. which we do with regex cdev, and we initialize it with our regex ops. Wow. And then we cdev add regex cdev as I actually don't know how this works. I assume it's like make dev regex dev 0, maybe? That'd be my guess. Can we look at like cdev.h? What is in here? So we have cdev add. He takes in a dev t and unsigned. So, dude, come on. Int cdev add. I guess the documentation is actually in the source file. So the number of consecutive minor numbers corresponding to this device. So we want one minor number at regexdev. That seems fine. Seems fine. That seems like this might work. Might work. And then this can fail. So error is equal to this. And can init fail as well? No. No, it cannot. We need to define regex ops as well, but we'll get there in a second. I guess we'll get there now. I changed my mind. So we have static struct file operations regex ops is equal to, can we just zero it out? Owner is this module. I guess we will say that at least. This module is not defined? Really? Oh, because again, my fucking thing's just a liar. And I wonder if like the rest of this, I wonder if like we have to define these or if they work kind of manually or magically. I also don't know what happens if you do this and you don't define everything. So maybe we have to manually set them all to null because I can't remember the C rules here. Can we look up struct file operations? Oh, where is this defined? God damn it. fs.h sounds promising. Nope. What about in cdev.h? Nope. Great. That's super cool. How do I find this? Struct file operations. It just feels like. Oh, here we go. I have to escape the thing. Here we go. Okay, so I'm actually kind of surprised here. This example, like, aren't all the unset things in here like just invalid, like uninitialized memory then? Is it that the Linux kernel has static memory auto zeroed out? I know that I've seen that before. But like this feels sketchy to me. What are like the C rules here? We'll ask this idiot. Okay, don't judge me. I'm just gonna copy paste this example and ask him why it's like in Linux character driver setup tutorial thing setup guide. They say this. Doesn't that leave all other function pointers in an undefined state? My guess is that the Linux kernel zeroes out all the memory. But we'll see if ChatGPT says that. Then maybe it's fine. Okay, so here he's saying that you could set them to null. But okay, so he's basically saying like he's just agreeing with me. But I think he's wrong. Linux kernel 0 initialize static memory. Thanks for the prime cleric. Thank you. It is required by the standard for static memory to be initialized to 0. Okay, well, that kind of lines up with my understanding, so we'll just ignore it for now instead of understanding it better. So here we can assume that every single function is not implemented. And so let's try making this. So it built, that's really great. And I wonder if we're gonna get a thing. So it ran. We don't have anything in dev because I think we actually forgot to enable devfs here. So let's go here and look for, I think there's like dev tempfs or something. Yeah. Maintain a dev thing at dev, and auto mount is, yeah, sure, why not? I don't give a fuck. All right. All right. So we gotta wait for the kernel to build again because we just changed some config options that apparently are leaky. It changes everything. So all these object files have to be recompiled. Super fun for us, but that's okay. We can stall. Luca, thanks for the sub. Thanks for the prime. Appreciate it. Oh, I was burped. Gross. All right. So this should be almost done. Almost. 3, 2, 1. Dude, that was so. Come on. That was fucking awesome. Give that one to me. Okay. Run. I'm in the wrong folder. We need to be in the jar folder. Run. All right. ls dev. So he didn't auto mount. He's a fucking liar. Mount -t dev temp fs, I think is dev temp fs. It dev ls dev. Okay, so here's our stuff. And do we have regex in here? ls dev regex. Nope. But if I remember correctly, these things are not actually automatically made. I remember there's like a make node command or something. Creates a special file. But how do we know the major or minor numbers? How do we know that? I'm not sure. Let's continue reading here. So he adds this cdev. Okay. And we have to deregister them eventually, but fuck it. Car dev Linux not shown. Why the register character device is not visible. No device are either created manually or by udev. Nice. To emit the event. So how do I know the like auto allocated number then? Right? Like we have a problem there. But I guess we can just print it. We can just print it for now. I'm sure that there's some better way, but for now we will do it this way. So we will say print k found got dev this. I think it's dash u, and then we pass in regex dev. And let's just try that. Make please. Make this one. Caveman searching is so good. We are very caveman searching right now. Okay, so we've got this number, which means I should be able to call it make node. And fuck. I guess I want to print it as major minor then. So we want got this, and we're gonna type major and minor. No, we only know the major number here because there is no minor number. So we got major number this. Make. Okay, run. Got dev 254. Okay, so then we can say make node. What is it again? Make node dev regex. And then the type is character device, probably. I don't know. And the major was 254.0. Okay, so this exists. And if we like try to like cat dev regex, he's gonna say cannot open no such device or address. That's not what I was hoping. I was hoping to see like open unimplemented or something. But maybe that's still the same error message. So let's try implementing open. Right, let's just try implementing. We'll see what happens. Who fucking knows? Not me. Where was this thing defined? fs.h? The other fs.h? Here. So open. Open takes in an inode and a file. So what if we just say like regex open here, and we say static int regex open takes in a struct inode star and a struct file star and return 0. Right? Like, does that do something? Maybe before we do that, we say like print k, hi dude. Maybe this will do something. Maybe it won't. Maybe she's born with it. Fuck off. Okay, so we don't have control R here, so we have to do it again. Make node dev regex as a character device 254 0, and cat dev regex can't open. I wonder if it's like 1. Maybe it's 1 initialized. Can't open. No such device or address. Okay, so we're not looking good. We're not looking good. We're missing some crucial information. We'll go back here and maybe we'll read it a little more. We'll read it a little more. So cdev add, make dev major minor. Okay, so did we do that? Yeah, we did. I wonder if 0 is no good. This is also kind of interesting that he's saying that initialize dev. He's doing 1 every time here, which is kind of confusing. I wonder, let's try, we put a 1 in here just to kind of match. And like, let's see if like cdev add will tell us anything. I just got in and saw dev regex. I'm so in. Hell yeah, baby. Hell yeah. Is it like cdev.c? Where cdev add? No, we're just int cdev add. So does he return us? What does he return? Or does he like log anything for us? No. Making it live immediately. A negative error code is return a failure. Okay. pdev, pcount, kopt map, blah, blah, blah. All right. Well, we'll try it this way too. And then, you know, if this doesn't work, we'll have to think a little bit harder. We'll have to think a little harder. Non-codes, thanks to the raid. What is up, you guys? What is up? Okay, so for those of you coming in, we are doing some wacky shit. We are making a regex engine in the kernel and trying to expose it over a block device. Now, saying that we are doing that is a little bit, you know, maybe disingenuous because we have not done anything yet. But we are planning on doing that. So we have a kernel that we've built, as well as a kernel module that we've built, and we are just in the process of trying to figure out how the fuck do we interact with like the handle that we're trying to make. So we are hoping to see somehow that if we interact with this file, that we get some log from the kernel that says we did something. But we're not seeing that. But what we do have is if we rmmod dev regex, we see buy from Zig and mod pro insmod dev regex co. We say have from Zig. So we're seeing something, right? Something's happening. Something's happening. It's just we are not correctly interacting with it. Okay, so why the fuck cdev add make nod example, right? We're missing. Where do cardevs appear after cdev add? Yeah. Okay. So cdev blah 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 init to associate a cdev with a set of file operations, which we've done. Our file operations suck ass, but that's okay. This does not mean it's created for you, right? That's our understanding. Or using device create function. Device nodes are generally associated with a class. I'd be interested in trying to use device create because I think it's likely that our make node usage is just totally fucking wrong. So let's try that. I like that idea because it means that I have something to copy paste from. Why the fuck? Because I thought it would be funny. It's about the extent of it. So where does device create come from? So he's saying device create my class, where my class is class create. It's sysclass. This is kind of interesting too. So he said, oh, alloc cardev region. This is what we did. Alloc cardev region, we asked for 1 for my driver, regex. Create a device node for this device. That's not really what I want. You're using device create. Device nodes are usually associated with a class. Oh, so we need to create class first using create class. I see. I see. So he says, yo, I want a class for this module. Okay. That seems straightforward. I'm down. Regex class is this. And did he kind of say this is up here? Struct class star. Regex class. So he's basically saying we can use class create to say regex class, and this will give us a handle that we can use on device create, which has this API. So my class, regex class, and he has null. Okay, can we look at like int device create? Where is this defined? Device create. How is it like void device create? No. Int device create? No. Oh, I hate when we can't like. Oh, here device. Oh, this is somebody's usage of it. Where does it come from though? Where does it come from? Probably device.h. That sounds promising. Here we go. Here we go. So this is in. Is there like device.c somewhere? Uh. God, I wish I had fucking my indexer set up right. Device create struct. And then like white space first, or like beginning of line. Device.c. Surely one of these is the right one. And I wish I could see the full fucking names. Linux device.c. No. God damn it. God damn it. I just want to see the fucking docs. Okay. We'll just use this. That's fine. Pointer, parent, dev t. Okay. So the dev t, no parent. The dev t is our regex dev. Derv data for callbacks, null for now. And the format is going to be regex percent. We'll just say regex with no arguments. Yeah. Sure. Fuck it. Fuck it. He doesn't exist because he's mad because there are too many arguments in function class create. Okay. Class create. And I wish I don't know how to like easily grep for stuff. I guess this is kind of claiming that there's like man class create. No. Oi oi oi. I guess we'll grep in the include directory only. There we go. Okay. Which doesn't fucking have the fucking docs. Oh my god. Class create. We need to go up. Class create const car. Here we go. Class.c. Well, remember, drivers base class.c. Class create. So this was supposed to be kind of like they're trying to like do string merging here. Was what they were doing. Not multiple arguments. Did you give up on Zig? We are going to be writing in Zig in a minute. But just not right this second. So this is actually claiming that we don't want this module here. So I guess the class create has just changed over time from whenever that Stack Overflow response was added, so that's fine. Make mount dash t dev tempfs on dev. And do we see it now on dev? ls regex. Oh, hell yeah, baby. We have regex. And if we cat this thing, no such, we still see the same can't open, no such device or address. So, but the kernel has like auto created this file for us. So we're kind of on the right track. We just have to figure out now why that's happening. So it's possible that there just aren't enough things implemented. We did, in fact, register the right thing. But I wonder why. So can we see, like, we could maybe try to grep the source code for where that happens? Was it no such device or address? So there's probably, like, Linux error codes. Like, no such device. I don't know. there's going to be some error code that maps to that, and then I was just trying to think, like, I guess like trying to debug from the open side is not going to be super clear. Let's go back to this thing and let's see if this guy starts. We can try implementing kind of all of these and see if that changes the behavior at all. Yeah, let's try that. And then this is in fs or Linux fs.h. It was fs ops file system. What was it called? File operations. Okay. So this doesn't really tell us what it expects from each of these things, but that's okay. That's okay. We'll just kind of, we'll figure it out. We'll figure it out. So it's possible that like he doesn't even try to open it unless he's been like, he knows that there's enough function arguments. Yeah, he doesn't know. So we can try copy pasting what this guy did and see if that just like kind of gets us in the right direction. Regex read, regex write, regex release, regex ioctl. Certainly ioctl doesn't need to be implemented, but maybe these do. So read write. I guess we'll copy with the system clipboard. Paste here. We will put this as regex read and regex write. Okay, and these will just kind of like stub out and return 0 for both of them. Right, we're not going to do anything, but like, let's just see. And then the other thing he implemented was release, which I guess is the equivalent of close, is like means close, I guess. Would be, that's my guess, And probably he needs to return 0, almost certainly, but maybe not, but maybe 0. Let's see if that changes behavior at all. What file operations did you implement so far? Nothing. We've implemented nothing. We are like all we've done is just stub out these open read write release. That's it. And we're trying to understand how, we're trying to just see any type of like hookup to these. I guess our init script should mount dev. That would make this go quicker. So we're going to internet here, and we actually are already trying to do that. Oh, that's debug. Dev tempfs on dev. Right? If we get dev mounted, then we don't have to fucking manually type it every time, which would be a big win for us. Big win. Run. Okay, cat dev regex. Yeah, okay, so still nothing. So can't open character device, no such device or address. Let's see what it complains about. But there is such a device. Print K confirmed that eno dev wasn't thrown from inside open. If the device shows up in proc devices, then you've got a number right from make node. Then the driver itself is refusing the open. The driver can return any error code, including no such device. But we aren't even seeing our print K. We could look at proc devices, but proc isn't mounted, probably because we forgot to compile proc and sysfs into our kernel. So let's kind of poke that way a little bit. Sysfs, procfs. Let's get that shit in here, baby. We want proc and sys, please. We need all the debugging help we can get. What's your favorite build system to work with? Dude, surely there's no right answer to that, right? They all suck. I hate working with building configurations in general. Builds are such a pain in my ass. I understand they're important, but man, do I hate every build system. All right, we have to give him a second to compile again. And while we're doing that, so he's saying make node doesn't care if there's device corresponding. That makes sense. But we were using device create, but maybe device create also doesn't care. In which case we could maybe look into the error handling around like cdev add, or cdev init even maybe. Cdev add, no response or something. I don't know. We'll see. I'll Google in a second. Let's start here and we'll go back to, I guess we probably have to recompile our driver too because the kernel's changed. So we'll do that. And then we'll try looking at proc devices and see what that looks like. Proc. Cat devices. Hell yeah. So we do have 254 regex. And we ls-l dev regex. He does think he's 254.0. I wonder if he's supposed to be 254.1. That was something that we were like kind of wondering about earlier. Okay. Okay, so he's saying if somebody was talking about proc devices in here, and you should have got the number right in make node, then the driver itself is refusing the open. So people are just saying, I assume it's a problem with the driver. It's like, yeah, I don't know what the fuck is going on. Like, okay, so he inits with fops. He adds with 1 here. We also maybe added with 1. I remember changing that, yes. So it's possible that this device create needs to be make dev regex dev 1 as well here. That seems likely. That seems likely, actually. So now we ls-l dev regex. Oopsies. ls-l dev regex. No such file directory. Oh. Why? Why? I'm a little confused. I'm not gonna lie. I guess kind of just like randomly poking in the dark is not really ideal. But one more attempt where we do 0, 0 here, just to see. Because it could be that 0, 1, if it's 0 indexed, then, what I'm trying to say, if it's 0 indexed, then maybe, when we are allocating one single minor number, that's a problem. But even this, again, is still having problems. He is saying that this exists. Make node dev regex as a character device at 254.0. Cat dev regex. And then if we do this again with regex 1 at 1, I mean, yeah, neither of these are working, which makes sense. Makes sense. We've got something fundamentally wrong. So fundamentally wrong. Okay. So we will just keep reading and try to figure this out. So he cdev add. Can we go back to the cdev add definition? You didn't cat regex 1? That's a good point. That's a good point. So this was C254.1. But yeah, that's still broken. So the fact that like most of these things that we've typed didn't even fucking make the right address, like the right item, is a little concerning to me. Right, we had a state before where at least the item was showing up. Oh, it must have been like this, right? When we ran this, like we were in a state where the Linux kernel was correctly creating the device handle for us. I just don't remember what state that was. We had like cdev add 0 maybe and device create 1. I don't really fucking remember. Or cdev add 1, device create 0. If only we had committed ourselves when we were in a good state. Yeah, I don't understand. I swear that at a point, this device create was creating something for us. Okay, can we try maybe just allocating like 10 minor numbers here to avoid any possible off by 1 errors? And then here, cdev add. Let's say that we're trying to add the first one, 0, and we'll just match the zeros up. Match the zeros up. Surely. Dev random. Fuck! I swear it was making it at some point. What have we changed? Let's just also double check. I just want to make sure that like we're compiling and everything's hooked up correctly. So we should say get high dev 254. So we are recompiling every time. And I just don't know. We fucked something up really bad here, which is kind of fun. That's fun for us. Okay. Okay, let's read this a little bit more closely. In Unix, hardware devices are from dev, blah, 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 open, read, write, lseek, blah, blah, blah. 2 categories, 2 types, majors and minors. The traditionally has a unique identifier. Although identifiers can be dynamically allocated for compatibilities, most drivers still use static. The identifier consists of 2 parts, major and minor. The first part indicates the device type, and the second one identifies the device. First is second serial point. Most times, the major identifies the driver, while the minor identifies each physical device served by the driver. Okay. As can be seen from the example above, device information can be used by using the ls command. Okay, let's try hard coding it. Fuck it, right? Let's just fuck this like allocate shit, and let's try using static ones just to kind of reduce the area of like things that can go wrong. So here they do register card of region. For regex, we're gonna start at like define regex. What is it? Define regex major like 250, regex minor 0, 1. We're going to make dev at regex major, regex minor. We're gonna allocate 1. Simple. Simple, 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 simple. You did add make dev macros at create, I think, at some point. Oh, okay. That's interesting information. Interesting information. So you think that at like device create at some point, do we have like device? Showing dev t. If the dev t is not 0, 0, if a pointer of parent struct is passed in, then it created blah, 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 blah. Oh, I don't remember. That's okay. We will work our way forward. So this is regex major, regex major, regex minor. And let's just kind of do this all the way. All right. So ls dev regex, okay. Cat dev regex, okay. So who knows what the fuck was going on? But now if we are manually setting the major minor all over the place, works okay. And that's good enough for me because I have spent too much time on this. Too much time. Okay, we fucking have something. Oh, I guess we should make it so that it echoes back input, huh? We should do that. What will dev regex do? Sorry, I just got there. We plan on piping stuff into it, filtering through some regex, and getting stuff back out. Right now, we are just trying to do anything. Anything. Okay, so we need, when we read and write this data, if we want to like just echo back what we got, right? That's the simplest thing to do. We need to like buffer that data somewhere. So somewhere there's user data that we can associate with this, I assume, right? Surely when we open a file, we can like set some parameters on it, I assume, like maybe a user data pointer. Maybe not, but maybe. So can we like look for like struct file like this and include Linux? It must be here. So when we open, can we like fucking just slap some stuff on it? Maybe. So we have address space, poll, private data. Needed for P2I driver, and maybe others. I can be a maybe others. Yeah, that seems reasonable. So let's just kind of huck some private data on this bad boy. So this is probably where we want to hook up to Zigland. So for now, let's just, in Zigland, do something like file is a struct, right? And for now, we're just going to have like his ID. right? And maybe we'll do something like alloc file. Dev regex impl alloc file. And he's going to return a file pointer, right? Like this. And what do we have to do now? We need to somehow like for now, I'm just going to return a usize. That will be easier. Okay, we're going to return, or maybe not even a usize, maybe like a u32. And we're going to have like global counter. Okay. Then we're going to say return counter plus counter and defer counter plus equals 1. So what we should see now is if we call this from here, right? We should see that this increments every time. And so if we say file private data is equal to struct what is it? What I forgot already. Void star. We'll just cast to a void star of from dev regex impl alloc file. Okay, we're getting a little crazy here. We're getting a little crazy. Here, can we then print that thing? So here we'll say what u64 uint 64t num is equal to this, I guess. We will say allocated this. So this is a ul. Then here we say num, and then on read we can kind of pull this stuff back out. Right, so we can say file private data, and can we just like uint 64t num is equal to uint 64t from this, and print k reading this file. Right, we're hoping to see that that same number increments every time we cat the thing. Sorry for ignoring your question, Cleric. Yeah, I am planning on sorry. My poor little brain is trying to do too many things at once. I am planning on God damn it, LLU. I am planning on returning all lines where the regex matches. That's the plan. That's the plan. Okay, so cat dev regex allocated 0, reading 0. So that's a really good sign. We have some proof of concept that we have like per file state. The next thing that I probably want to do is how do I end up over here? The next thing we want to do is we want to make sure that we can like do as much work in Zig's land as possible. So here we want to see like we're gonna want like every time they write file, we want to store that in some allocated data. And if we read file, we want to like we want to basically like, pop that shit back out. So we're gonna want like some sort of file struct. And for now, can we just kind of put the counter in here, or like ID maybe, just so we can like kind of prove that this is working. And we kind of need some way to like do this allocation, which means that we need like kz alloc or something. So can we like like Linux kernel alloc? It's like I think it's kz alloc or something. Yeah, this. And we need like a size here. So there's gonna need to be like, how does our memory model work? We probably want an allocator interface in Zig, and we probably want to like feed that allocator interface in some way. So we probably want to do like var alloc is like an allocator. And here we probably want to like initialize this allocator somehow. I don't really know yet. All right. And here we must be able to create some sort of allocator interface that works with kzalloc. We just need to, I guess it probably makes sense to just try to call these functions directly. So can we look for like the definition of kzalloc? Like how do we like void star what does he return? Where's kzalloc defined? Where is it defined? Memory allocation. This is where we just were. Where is it like fucking header dot h? I'm like, oh my god, it's here we go. Size t. Okay, size no. K malloc. What's the difference between k malloc and kzalloc? Normal method of allocating memory matters. Okay. Z-alloc probably just zeros it out first. That makes sense. kzalloc. Here we go. We found it. We found it. So it is just defined this way. So if we want this thing to be available to us in Zigland, it's going to be kzalloc takes in a size. Oops. Size. Usize. Size is a usize, and gfpt is like something else, but we can just call this like gfpt. Is there like type def gfp types unsigned int? So c gfp flags is c int. Okay. And then is there like a kz free or k free? Yep. And this is gonna just take in a thing and return void. All right. All right. So maybe for now we will just call kzalloc manually. So can we do like size of file? And we probably want like GFP, like what are these? GFP kernel, which is 0. Great. I think. Is that what we saw? Yeah. Sure. So can we say like file is equal to this? Then we return a file back. And then we say return file, and file dot id is equal to counter. Okay, and then here we will do something that's like dev regex impl write file. And here is going to take in the file as a input. And then here we just want to like print k file writing file ID file this, which is a u. I don't know. Let's kind of see what happens if we do this. Let's see. So here we can do like paste this. This is a void. This now takes into like a void star, I guess, because we don't have the thing defined. This takes in a oopsies void star as a file pointer, and then here we don't do this. We just say private data is dev regex impl alloc file, and on read we do dev regex. We called it write file by mistake, but shut the fuck up. You know, we'll just do this, and we're hoping to see that we see like some sort of log indicating that like that is the right thing. You know, file ID does not support field access. Okay, surprising. So file is kzalloc. I did write that kzalloc returns an I32, which does just kind of seem like fucking wrong, huh? Fucking idiot. And then here we'll say, or else return null. This. Deal with that later. Any opaque does not support field access, so here we need to pointer cast this. So this is going to be a file star like this. Oops, star file, I guess. Here he's mad about align cast. It's fine. It's fine. Okay. kzalloc undefined. This is static inline, huh? Where does kzalloc get defined? kzalloc. We are just in the wrong file. Like slab.h or something. Where's like Linux kzalloc? Oh my god, I've clicked on this link like 4 times. Header. Like, I'm just confused about, like... memory allocation. Oh my god, I'm gonna lose my fucking mind. I'm gonna lose my mind. Slab. It feels like it comes from slab. That's like what my gut says. But... like, it should return, like, void star or something. Oh my god, I could insert something. Oh, here we go. Oh, it's static inline, and he returns kmalloc. I see. So that's why it's not defined here. Is because it's kzalloc is just a wrapper around kmalloc. I see. So this kzalloc needs to turn into a kmalloc. And surely kmalloc isn't static inline. Yeah, nice. Nice, 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 nice. Oh, so now he's mad that kmalloc is also undefined? That's kind of surprising. Slab.c. So here we have kmalloc in slab.c. It's possible that like this is not baked into the executable or into the kernel right now. Is there like a k config here? Let's look for like slab.o. Okay. Slab.o core o files is in testing. We could just like look at make menu config and see. Oops. Make menu config. Is there like some sort of like compiled out slab? Fail slab, fault injection. No. Mem alloc profiling, memory management options. We could just try to look at like memory management here. Slab allocator. It does look like it should exist. Should exist. So why does it think that kmalloc doesn't exist then? You know? You know? What was I trying to do? Make. So I just want to make sure. So he's saying kmalloc undefined. Kmalloc undefined. Oh, is it just one of those things where I like looked at the wrong definition again? It does kind of look like the symbol is kmalloc, huh? Is there like a define k malloc that kind of moves it around? Yeah, define k malloc. Ugh. Ugh. K malloc, midline, k malloc. Where does like these come from? New k malloc cache, k malloc. Everything's so hard, man. Everything's so hard. Everything is so hard. Arch, arm. Nope. x86. Boot. Or is it in VM Linux here, I think? Yeah, yeah. LD, nm-c VM Linux. And can we grep for kmalloc? Yeah, so it does look like probably somewhere kmalloc gets defined to like one of these many kmallocs. Would be my guess. I mean, it doesn't. Oh, here. Alloc hooks, kmalloc, no prof. Yeah. Yep. So maybe this is sketchy as fuck. It's very likely that we should be doing the malloc outside. In fact, I feel like that feels safer, right? It does feel safer, so we can maybe like pass in an allocator function here. Like maybe we do something that's like in it here, we like pass in allocator, which is like a function pointer that takes in a size, and oh, that's just gonna get so ugly. Okay, we'll try no prof first. Just to try to like get somewhere. He thinks that doesn't exist either, so probably this gets turned into kmalloc no prof. Always inline. Everything sucks. Everything sucks. Okay. Okay, here's what we'll do instead. We will here we'll make a function that's void start dev regex alloc. Yeah. Okay. He's gonna take in the size. Very simple. He's gonna call kmalloc kz alloc size gfp kernel. He's just gonna return that thing. Okay. Then in our version, we can say we have dev regex alloc. We're not even gonna fucking worry about free right now, and he's just gonna have a size. That way we don't have to get crazy here. We can say dev regex alloc here. Like this. And we can try that. That seems much better. No previous prototype for dev regex alloc. Oh, that's fine. I guess he wants it there to be, but that's okay. And let's see if that does what we want it to do. Cat dev regex. Writing 0, writing 1, writing 2. Okay. Okay, so that seems like a scheme that works. We can allocate the thing from over there, and then we're fucking chilling. We're chilling. So now we have a file that we have we can like store data in, right? That's all we have to do. We just have to store some data. And so now we're gonna do something like, it would be nice to be able to use like a std array list, which means that it would be nice to have some sort of like runtime allocator thing. So I wonder if we can do like, how does this work? We need do we need a resize function in here? Like, is this guarded? Resize, so we need that as well. Is there a k realloc? Does look like there is. So we can just implement in our C side realloc that takes in a pointer, a new size, which calls krealloc with pointer size and GFP kernel. And we make another one that's free. And that's k free. Simple. K free. K free, which just takes in the object. All right. So now on the zig side, we have realloc, which takes in a p as a any opaque and a size, turns a new pointer, and we have free that takes in the pointer. All right. Now all we have to do is to hook up our like global allocator to this thing. We should be able to just like kind of wrap these functions. So I guess we'll call this like we need to implement these functions, I guess, with the correct APIs. So we'll call this like a impl alloc, or yeah, impl alloc and free. It's fine. Doesn't really matter for now. Function here, boom, boom. Delete to these. These go back. This comes like this, like this, like this. And this needs to call like dev regex alloc with len. And he just discards the alignment for now. He just discards everything else. Okay. And then I guess we just return pointer cast, align cast. Okay. Seems reasonable to me. We can just do the same thing here, where this is dev regex realloc, and he's reallocing buff pointer with new len, and we are getting rid of buff align and CTX. Okay, then free. It's just dev regex free, I guess, of buff pointer. I'm sure that we're like missing very important things here, but you know, this is okay for now. For now. Okay, so our allocator now needs to take pointer is equal to null. We have no context. Oh, but he needs to be something. I'm surprised. We can't just have like a null context. So I guess we'll just make him undefined, because technically he won't ever be used. And then the v table we set to it was alloc was equal to impl alloc. Resize and free is free here and resize here. Okay. And we'll call this like, yeah, we'll just fucking have a global allocator. Fuck it. Or global, we'll call it kernel alloc, I guess is the fair name here. So now our file, hopefully we can do like something silly, like say like buff is a stood array list of bytes, right? And then we can do like file ID is equal to counter and file.buff is equal to stood array list of U8s initialized with kernel alloc. Maybe? Right, that's what I'm kind of hoping. It does look like he is mad a little bit because void value is not ignored as it ought to be. He's a little whiner, this guy, you know? So this is here. This does not have to return, which is fair. Then control flow reaches end at 26. Oh, because this is supposed to be void. Okay, vtable does not support struct initialization syntax. That's fair as well. So this needs to be a pointer to something. So var kernel alloc vtable is a allocator v. No? Can I not make a vtable here? Where does vtable come in? Pubcon's vtable. Yeah, like this. Okay. And then here, our allocator gets a pointer to the vtable. Spelt wrong, I understand, but it's fine. Expected pointer type found bool at 34. Yeah, that's true. That's true. So how, what the fuck? Oh, because the buff, is the buff expected to have the same pointer after? Resize. Red adder, okay, a new line must be greater than 0. A result of true indicates that resize was successful, and that the allocation now is the same address but of size of new line. False indicates without moving the allocation to a different address. Can I just return false all the time then? So here, resize must try to resize and then fail, I would think. It is guaranteed to not move the pointer. However, the allocator may refuse the resize. I'm just going to fucking return false in our resize implementation then. Surely everybody else will just kind of work if I do that. Surely. Surely. Pointer type found void at 44. Yeah, that's true as well. I wonder if you could include the Steam allocator specifically. It seems possible, but I don't want to deal with it. I don't want to deal with it because I've already struggled with that kind of section of the code enough. Okay, let's see, like, if we run this shit, what happens? Cat dev regex. So nothing like is catastrophic yet. I guess now let's try to hook up the write and read calls. So on write, let's call dev, write the file with the size and the offset. I guess for now, that's fine, it's fine. I haven't really thought this all the way through, to be honest. I haven't thought this all the way through at all. But so when we write file and read file, write file is probably going to take in our context pointer and then also maybe like a buff that it's going to write to, right? So there's going to be like a car star and a size t, and then a read buffer as well, probably. Okay. So here, this is going to be like data size offs, I guess, probably. I don't know. I know that there's something funny about like kernel user pointer stuff. So there's something about like copy to and from user that he probably does in here that we can like kind of copy. Yeah, here. So access the address of process. A driver for a device is the interface between application and hardware. As a result, we often have to access user space data. Right, like now. Accessing it cannot be done directly. Direct access of a user space pointer can lead to incorrect behavior. A kernel, oops, blah, blah, blah. Right, so there are things that fail. So we need to put the thing in kernel memory. So copy to users copies n bytes from the kernel space from the address. But I don't really want to copy this stuff out, right? Because like, I kind of want to just like write directly to the buffer, maybe, right? It looks like they kind of say that we on read and write, I guess they copy the data out. So they copy from the user buffer. Oh, that's a little tricky. So they kind of just do the copy directly like this. And if we're trying to do the work in Zigland, then like we would have to, if we wanted our interface to be like taking a pointer, we would have to copy into kernel space, then do another copy in our driver, which kind of sucks. We could look to see if copy to user. Was that copy to? Oh, we want like this is on read. What about on write? What do they do on write? They copy from user. Yeah, it would be interesting to see if like the copy from user definition, which probably returns an int. These are copy to user, copy from user. Copy from user. Like, I just want to see where this is defined. It's so hard working without the fucking indexer, man. Int, copy from user. Yeah, this is just not the right spot. Fuck off. Copy from user definition header or something. I don't know. In what header is this declared? U access. Copy from user. Here. So this is a static thing that calls, yeah. So once again, we have to wrap this shit. So we have two options here, right? One is to copy into kernel space before interacting with Zig, or we just give Zig side the ability to call this function, which I think is what we will do. So we just kind of have to follow like the same pattern here where we say copy from user, regex copy from user takes in a to, a from, and a size. So size t size. This returns a something. Copy from user return. Can fail, so 0 success probably. So we will return just the same thing, I guess. Unsigned long is kind of shit because like we don't really know. Like the bit widths are kind of hard to match up with Zig, so I'm gonna just say uint32t, I think. uint64t, I guess. And then we will just return copy from user to from size. Chillin'. And then we want to do the same for copy to user. So this is to from size again, and this just goes copy to user. Boom. Boom, boom, boom. All right. All right, all right, all right. So now we can say that we get like our read write file comes from a, what did we say it was? It was like pointer and size. And we have read, which is again pointer and size. And these need new lines like this. And here we're just going to say that like, here we want like our index into the buffer. And that's not true. That's not true. So when we write, we're going to say like regex copy from user into some pointer, right? Which means that we need size bytes in buff. So buff, we just need to make sure the capacity is that size. So file buff ensure unused capacity, right, of size. And then I guess we catch unreachable. I don't know. Catch. I don't really know if we can like panic in here, so we'll just return and say print k failed to write is what we will do for now. That's what we'll do for now. Then we can basically try to copy regex, copy from user, which we need to define up here. So extern. I guess everything else is prefixed dev regex. So dev regex copy from user takes in a p2, a from, and a size. And he returns a uint64. And we just define both these. Copy from, copy to. And here we say dev regex copy from user, pointer size, and to file buff items. This is the kind of, how's like the array list internal look like? Items is a slice, and we just resize the len, right? It's like set len. Resize maybe. I know there's a way to just like fucking like hard change the size of this thing. Ensure total capacity, clear and free, shrink and free, append, writer, append, insert, add, insert clone to. I thought there was a way to just like set len. Am I fucking high? Am I high? Zig standard lib. Array list. Array list. Expand. This is what I was looking for. Yeah, so this just sets it to the capacity. Right. So we can assume here that when we want to copy, so we ensure that there's that many bytes remaining, right? And then we say go from. Can I work with the pointer directly? Is that easier? Expand to capacity. So can I like just fucking, I guess I expand first. That will be easier. Var old len is file buff items len. And then we say file buff items len is equal to file buff items len plus size. Then we go from old len onwards and we grab that pointer. Yeah. So this goes out from pointer size. Seems reasonable to me. I guess this is maybe a little silly. Maybe I just take the original pointer plus old len. Okay. Then here, I don't know yet. But for now, when we say, well, we'll do like reading this with size this. And then we could do file.buff.items line here. There we go. So we will never actually like read anything, but we can see if we're at least putting some shit in there. You know? He's mad about a lot of stuff. Too few arguments to read file. Yeah, that's true. So this needs like data and size, and this needs like data and size. Okay, file undeclared here, which is true as well. This needs to say file. But otherwise, nope, error. He says zig probe stack undefined. Fuck. So it looks like our build, we need to like unwind tables maybe. Like we just kind of need to disable as many features as we can here. So unwind tables, error tracing certainly has to be off. Right? Let's just kind of see how much we can get away with here. Zig probe stack still in there. So what else can we turn off here? Sanitize thread, strip maybe. Omit frame pointer maybe. Bump, 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 bump. We might have to Google. Disable zig probe stack. Like compiler runtime. How do we do that? Obj. I know I've seen that somewhere. You can like disable the compiler runtime. I know I've seen it. Bundle compiler RT. I've seen like F compiler. F. No. Okay. I don't know which way this is supposed to be. So can we do like... I don't want the compiler runtime, or maybe I do want the compiler runtime. I don't know. It's so hard to tell. What happens if I set this true? What happens? I don't know. It's either like there is a compiler runtime that needs to be available, or there's not a we need to tell it to not use the compiler runtime. Saying bundle it seems to do a little better. So let's see what happens if we run this. So can we like echo test into dev regex? We kernel panic. Hell yeah. Hell yeah. So something happened. And who fucking knows why? Who knows? Oops, general protection fault. Okay. How the fuck did I go over here? So I guess we just start kinda... First, let's just get rid of this stuff. Let's see if just ensuring capacity is fine. Maybe, right? Maybe it's fine. Maybe it's not. He's mad about like pointer. We start slow. We have to start slow. We've done too much at once. Echo test into dev regex. Still no good. Let's go a little farther. Right? We just go fucking do nothing. We won't do anything at all. Let's just make sure that like we know echo test dev regex. Okay, so that's fine, right? That's fine. So now we know that using their allocator is fucking up. So now maybe it makes sense to kind of try to bisect a little bit here. Let's kind of here say const file is going to be a kernel alloc create file, right? This will help us bisect if there's something wrong with like the way our allocator is hooked up. And this has to be like, or else return null. So he's mad actually, because it's not or else, it's a catch. Okay, let's try that. So we do run. And what is it? What was it? Echo test to dev regex. Okay, no crashes there. Which is good for us. So it means this is doing something stupid. Grow capacity. And ensure total capacity here. So here he calls resize. If that fails, then he calls an aligned alloc. So this will fail, so he should get into here. And he's just calling aligned alloc. Okay. So I don't actually understand why that would fail. I guess it's possible that the free is a problem here. So it would be interesting to do like print k freeing. And maybe we even say what we're freeing. Right? Maybe we do this. And maybe here we'll go we'll say allocated from red. Right? You know, something like this. On necessary discard of size. Need to set the array list size after. Oh, maybe. Although I don't see why that would cause the problem that has been caused. But that does seem kind of... I'm not convinced that that would fix the problem that we're seeing. While I do need to do that. I agree with you that it needs to get done, just not that it's the problem. Okay, so do we have any useful little allocated pointer val writing 0? Then we get kind of nothing. So it's add or ensure total capacity. It makes it seem like we're not even getting into the fucking allocator. Right? What's he complaining about? He's saying like general protection fault, which is not very helpful to us. Maybe for this address. Maybe. Who knows? Interesting. So here he does an alloc and then a free. And we don't really know which one of those we're in. Also, this %p thing is not working the way I wanted it to. So we'll just kind of do this instead. Allocated. And freed. No arguments. I guess we can also maybe comment out the free to bisect a little further. That's something that we could do. Interesting. So we can assume I'm going to assume that it's on the allocation side. That makes way more sense, right? Like we're trying to allocate some memory and we're just like fucking it up. Echo test dev regex. So what confuses me is that like the allocation works. I guess if like the alignment is wrong, like I don't really know what happens if we like panic. Right? Like I don't know what happens if we do this. So can we do like cat dev regex? Okay. So this just says oops int 3. Okay. So here he's saying like, so this isn't like a seg fault or anything. He's just intentionally like faulting himself. So it looks like this panic intrinsic is implemented okay, which means that like if we had like incorrect alignment, I would also kind of assume that that's doing the right, like we would see a, like not what we're seeing, like we would see like an int 3 would be my guess. Hard to know though. I wonder here, can we just do like try append 8 or something, right? And then print k buff len is %lu, and we'll look at file buff len, right? Let's kind of get crazy here. Oopsies, make len doesn't exist because it's items len here. Okay, and let's just see here, if we cat the file, do we still crash? Okay. So this is interesting. We are seeing here that we can, at the very least, resize it once. Very interesting, very interesting. So how come ensure unused capacity is a problem here? What if I do this here? Let's just try doing this here. We need 150 bytes, please. I guess that's fine. I don't really care. I don't really care. We're just trying to test. So let's run. And cat dev regex. So that's also seemingly succeeding. We can probably check with a buff capacity here. Right? We can make sure that the capacity does get set to 150. Cat dev regex. Yeah, so here we're getting buff cap of 165, right? So that's very interesting, very interesting. It would be interesting to see, like, maybe we'll say we are returning file with address, right? And instead of, we'll log it as a LU, because the pointer version was not working correctly. And then we'll say writing with file LU. And we're just gonna see what happens there. So here we can do echo test into dev regex. Oopsies. Oh, it's not breaking anymore. What? What if we don't do this stuff? And then also, can we just fucking fix this to return the amount of bytes written? Because this is fucking pissing me off. Because it's just kind of like spam writing, which is a problem. So let's go to interface here, and write needs to return this. And this needs to return a, what do you say? We said U64. And we'll just like let it fucking incast. I don't give a shit. He doesn't like it, so expected U64 found void. What? 89? Oh. Okay, it's fine by me. Okay. echo test dev regex. Oh, okay. I guess it's just working now. Maybe I like wasn't testing what I thought I was, or maybe we changed something along the way and I didn't notice. It could have been that it was in here and we just didn't know. We like fucked up our testing. Or this is one of those phantom bugs. But it does look like this is working. So can we then... So if we're trying to write and read, and we're trying to see that we got the same, let's hope it wasn't the prints that fixed it. I've definitely had that bug before where you have like some problem that only happens on some stack alignments and you like add a print and it just like moves the stack pointer around and you don't really fucking notice. But maybe also we just weren't clear on what we were testing. It's very possible that I was just confused because I don't know what the fuck. I'm just chasing stuff down, you know? Okay. I wonder if we can make like a test app. So I want to do something that's like, test app. I kind of want to make the test app in C, to be honest. Just to, maybe I do want to write it in Zig. I do want to write it. I've changed my mind again. Let's do it in Zig. And this app should just open, write, and then read. That's all we want from it. That's all we want from it. So let's call this test app, right? And he's going to have, you know, some sort of like root source file of b path test app Zig. Okay. And target is equal to target. And this is actually wrong. This is going to be like driver target. And we will call this the runtime target is going to be whatever the fuck we wrote here. I guess this is just going to be standard target options. That seems fine to me. Opt equal to opt. And b install artifact test app. Okay. I guess we need a test app.zig, and we also don't have this here. This is optimize. And if we edit test app zig, we should be able to do something like const is equal to import stud. We want like a stud fs open absolute of dev regex. And then can we just do like f.write all hello and then f.read all into buff. Var buff is going to be like 256 u8s. And I assume this returns the length. Yep. And then can we do like std debug print got this string from buff 0 to len. All right. Zig build. He doesn't like the hello there because I didn't write try. So we try again, and then in our run script, we just also copy zig out bin test app to bin. I guess. I mean, why the fuck not, right? Test app. Illegal instruction. Sick. Okay, let's let's settle down a little bit. Std debug print hello world. Let's start there. Let's start there. Run. Test app. No bueno. No bueno. And the question is, why the fuck? Why the fuck? Zig build d. Let's see. Can we do like LDD zig out LDD zig out bin test app? Not a dynamic executable. That's good for us. But we are still not working, and so the question is why? Why? He's saying that he's got illegal instructions. What if we do nothing? We literally do nothing. Bin test step. Illegal instruction. Interesting. That's super interesting. And it's doing an invalid opcode. We are running QEMU x86-64, so we are 64-bit. I assume that if I run zig out bin test app, it's fine. Yeah, of course. Of course. And, super interesting. I kind of expected this to work. Let's try getting out of zig land and try to get into C land. Right, so let's just do int main void return 0. Let's start here. gcc-o test.c. I think that's like static, like this. Not a dynamic executable. Test return 0. In fact, let's go to test.c and let's return 3 or something, right? Just so that we can have like key returns, you know, echo this 3, chilling, right? So let's try now in run.sh. Let's also copy test, and we'll copy it to test, whatever. And here, if I run test, hello, whoa, what the fuck? Oh, I'm an idiot? Because I shouldn't copy to the root of my fucking computer. I should copy it to the root of the init ramfs. It's a really good point. So that's fine. He returns 3. So we know that we can run an executable that we built. Renee Roxai would be my guess on how to say that, is saying that I should target x86 Linux instead of my specific target. That does seem kind of likely, huh? That's kind of... So if we did, like, runtime target is x86 Linux, we could see what that does. We could see. I'm down with that suggestion. Zig out bin test app. Nothing happens. Great. Run. Test app. Test app. All right. Thank you for the suggestion, because that was going to be where I started looking next, but I'm glad that you just gave me the exact right line type. So now we go back to this. We go back to this where we're actually trying to run our test. Could be SIMD or AVX related. Oh, that makes a lot of sense, actually. Yeah, now that you say that, it's like, of course. Because it probably does like mrch equals native, or like tries to figure out. There we go. Sick. Okay, so we have definitely done some stuff here. Allocated, but it's not open for writing. So we need to adjust our thing. So here we just need to say mode is like, how does this fucking work? Open flags. I can open read and write, right? Read only, read write. Hell yeah. Read write. Let's try it again, baby. Test app. Oh, yes. That's so good. Okay, so we wrote some stuff into there, and at the very least, the buffer has been resized to the size of the content we wrote. So that's really good for us. And now we just have to like maybe return that stuff back. Return it back. Right, so here we can just do dev regex copy to user, and we want to look at file buff items pointer. We want to copy, is this which side is which? Copy to user is to from, according to us, who, you know, we're fucking liars sometimes, but we'll try it. And we want to copy, we want to say the size, out size, is the minimum of size and file buff items len. Right? And we say we're copying out size. And then we return out size. So we should fucking write that shit down. So that's on the C side. We want to get a uint64t here as well. And then on read, we return this. I think that's a make. That's a make because we were changing the driver. He's mad because U64 is ignored. And instead of checking it, I'm going to say fuck you. And we're going to ignore that return code. Like fucking bad citizens of the world. But now we can run test app. Wait, that's really good. Got hello, hello, hello. So the problem here is that we didn't shrink the thing after. So we want to do like file buff. And we want to kind of just like, can we like shift to the left? Is there like a mem set? Or like I want like an overlapping mem set. Like an zig overlapping mem set. I guess like stood mem copy backwards. That is what I want. Copy all of source into dest. So this is U8, and we want to copy from file buff from 0 onwards. So from, I guess, outsize onwards. So if outsize is less than file buff items len, we copy backwards and then resize down. Else, we just say file buff clear. Mem move does sound maybe like it would do what I want, but I'm okay with using just stood mem copy backwards. What does he do? He just does, oh, that does seem kind of shit, huh? We can try a mem move. Nope, doesn't exist. According to the autocomplete, which I don't really trust, but it's fine. So we want to copy from outsize to file. Copy backwards takes the dest from the source. So file buff from outsize onwards. And then here we want to like file buff resize to I copied outsize out, so just file buff items len minus outsize. Right? I think that's what I want to do. I think copy forwards or backwards. I think I'm trying to copy backwards. I'm trying to copy it so that I like shift to the left in my buffer. You know? So that like things that come in always go at the end and things that come out always come from the beginning. That's what I was thinking, at least. Resize or else panic. And it's not or else, it's catch, actually. All right. Moment of truth, baby. So if we run test app, dude, that's so fucking sick, man. Let's go, baby. So what we have done is we have a character device at dev regex. We, in our test app, we open that file, dev regex, and we write all hello, and then we read and we get back the hello. Okay? And so what's really sick there is we have hooked up our Zig driver. Well, calling it a Zig driver is kind of, a little sketchy, but the Zig side of our driver, we have our read and write implemented as operating on this file structure. And so we write into this file structure for this specific file, and then when we read it back, we get what we wrote in there. Which is just super, that's like perfect. That's perfect. That means that we have got to the point now where we have file specific data. And all we have to do now is implement the regex engine. That's all we have to do. All we have to do is implement the regex engine, right? And then all we can do there is we can say compiled regex is our regex regex representation, right? Or something, right? And then just on read, we just run this regex on the stuff that's coming out on the way out. Simple. It's simple. It's so simple. But that is a problem for another day. I kind of was hoping that we would get here faster today, but we kind of struggled with the dev regex initialization stuff. Don't want to use Zig built-in regex. No. I want to do it myself. Because that's half the point of this. Maybe 75% of the point of this was that I want to learn how to write a regex engine. I don't know how to do it. So that is a plan. That is a thing to do tomorrow. But yeah, pretty cool. I mean, nothing in here is crazy, right? Basically, all we've done is we've hooked up some piping from C to Zig, as you would in user space, and we've had to implement a few funny functions like copy to user and kzalloc or malloc and stuff, but whatever. And then we hook up, we do your typical C inheritance registration shit. This is very similar to what you'd see in Zig as well, where you just say okay, I've got I've got a V table, and yo, could I do something with that V table? It just turns out the thing that we're doing with the V table is making this character device. Yeah. So things are looking pretty good. Yeah. Okay. So thanks for watching, guys. If you like what you saw, we stream most days at around 12:30 Pacific time to 2 Pacific time. We're working right now on this regex engine in the kernel, just as a little bit of a break from the map stuff. But we will be back on the map stuff soon. I assume that this won't take more than a couple more days, and then we'll be back at the map stuff. But this is kind of a fun little detour. If you are watching on Twitch, there is a YouTube link in the Twitch description where you can check out everything that we've been working on. So we're working on dev regex, but there's other stuff in here, map, QR code decoder, operating system, neural network. Go check it out if you want. If you're watching on YouTube, there's a Twitch link in the YouTube description. You can swing by and say hi if you're online between 12:30 and 4. You will notice that 12:30 to 4 is longer than the timestamps in the YouTube video. So if you want to see what we are calling happy hour, which is kind of a pre-stream, kind of bug fix, refactor, kind of less new feature, more chill, kind of slosh through stuff that gotta get done. Those are archived on Patreon, or you can catch them on Twitch. This will be on GitHub. Cleric was asking me to upload it earlier, so we've got kind of this not so great state of it right now. We'll probably push this here a little bit more cleaned up later today. Subscribe, Twitch Prime, all that stuff. And cool. Yeah. All right. Bye, YouTube and Twitch. Let's find someone to raid.